Right. So good morning, everyone. So for today, we are going to have our MATLAB session on Newton Cotes integration. We still have around 15 students. So I think we better wait for another 2 or 3 minutes. Anyway, for today, Mr. Shevan wouldn't be able to join us, so I think I'm going to tutor you by myself today. Right, so I'm looking at my my computer screen. Actually only 48 including me, so we still have around 12. Okay. Okay, right, I think we better start. In the previous lecture, the one that I shared with you, the PowerPoint with narration file, I have listed down the numerical method used for integration. And in this particular course, we are going to use Newton Cotes integration, where for Newton Cotes integration, we actually have two types of Newton Cotes integration. So, so we have Newton Cotes. Sorry, I've forgotten to present. So can you see my screen now?
Yes, Doctor.
Can or not?
Can.
Okay. Okay. Thank you. So this would be our Newton Cotes integration, and we have two methods. The first one is open method. I'm sorry, I think I have problem with my pen. Open method and also closed method. So we have open and also closed method, where if we have open method, the integration limit is extended beyond the range of the data. So if let's say that we have, so this is for open method. So for example, if we have something like this, so this is our function. So for open method, so if we wanted to integrate from A to B, so if we wanted to use open method, therefore the integration limit extend beyond the range of data. So we only given this data. So the black dots here are actually data. So as you can see that the limits extend the range of the data. So it's so what we need to do would be extrapolation. So in order to find the value of FA and also FB, we are going to use extrapolation. So this is for open method. For closed method, it's going to be straightforward, where for closed method, the data that's given actually point or correspond to the end and also the beginning of the limits of the integration. So for example, if we have a similar function as previously, something like this. So from A to B, the data that given would actually correspond, the two of it will actually correspond to the beginning and also the end points of the limit of the integration of A and B. So this is fx. I'm not sure what happened to my pen, but there's something wrong. Okay, anyway, so in our course, we are going to focus on closed method, where open method, it's still good for numerical integration. However, there will be more work since we need to extrapolate the data here. Therefore, in this course, we are going to focus on the closed Newton-Cotes integration method. So there are several methods that we can use. However, the first one, the most basic method that we are going to use would be the trapezoidal rule. So this would be our most basic integration, Newton-Cotes integration method. So trapezoidal rule, as you can see here, is, if you refer back to the slides, the formula would be this. And this formula actually corresponds to the value of, this would be the value of the width, and this would correspond to the value of the average height. So we have two components here, width and average height. So if we try to put it in graphical representation, we will see that for trapezoidal, so if we have something like this, this is a function. So in order for us to use trapezoidal rule to integrate this function from A to B, we are going to assume that there is a trapezoid inside of that particular function. So this trapezoid here corresponds to width. So this is width. So the area in the trapezoid itself represented by the width times the average height. So this is FA and this is FB. So the average height would be FA plus FB, the height of these two here, divided by 2, because we wanted to have the average height. So this is how we get the formula for trapezoidal rule. And if, let's say, in a condition where instead of, as you can see that if we use one segment, the trapezoidal rule is not that accurate. However, in order to make it much more accurate, one way of counting this missing part, this part, is to introduce segments. So instead of having only one single trapezoid, we're going to have several segments. So for example, so if we wanted to find the integration of the function from A to B, we are going to divide this function into two segments. So these two segments actually corresponds to two trapezoids. So what we're going to have would be we represent the segments or the strips as 2. So in this case, it's 2. So this is n equals to 1 and n equals to 2. So this would be the, if we use strips or segments. So we can use 2 segments, 3 segments, or up to the question itself. So this would be trapezoidal rule with the multi-segmental application. If you refer back to this particular formula, we actually can, for Newton-Cotes integration, we actually can deduct that I, the integration of that particular function, is actually b minus a, which is the width, times the average height. So this is the generic equation for all Newton-Cotes formula. So all Newton-Cotes formula will follow this particular generic equation. The only difference between the Newton-Cotes formula would be how you calculate the average height. So for example, for trapezoid rule, the average height is actually this. So this is for trapezoid rule. So if we have another method that we have learned previously in the slide, we also have Simpson's one-third rule. So Simpson's one-third rule is actually a higher polynomial to connect the points. So if you refer back to the trapezoidal rule, this is actually a straight line. So this is actually where we have a first order polynomial, because we are going to assume that it's a first order polynomial. However, for Simpson's one-third rule, instead of assuming that the integration would be in first order polynomial, we're going to assume that it's going to be a multiple or higher polynomials in order to connect the points, the given points. So if we try to do, I'm not going to derive the formula here. However, I'm just directly going to apply the formula. So the formula for Simpson's one-third rule is actually b minus a times fx naught plus 4 fx1, this is fx1 plus fx2 divided by 6. So this would be the formula for Simpson's one-third rule, where if we refer back to the generic equation for Newton-Cotes integration method, this corresponds to the width. So this is the width. And this would be the average height. So here, if you refer to this particular equation, you will see that we actually have 3 points. So if we try to draw it, it's something, so from A to B, we will see that the representation of the points would be something like this. So this is A, B, and then we are going to calculate to divide this by 3. Sorry, this is not. We are going to divide this by 3 segments because it's 1/3 rule. So from there, you will see that, sorry about that, I think a bit mistake here, because even though we are going to about that. Even though we're going to say that it's a 1/3 rule, it's actually correspond to this, where 1/3 rule is actually we are going to have 3 points. So this is point number 1, point number 2, and point number 3. So this would be fx naught, and this would be fx1, and this would be fx2. And the distance between these two would be b minus a divided by 2, or 0.5. So this would be the distance between fx naught and fx1. So it would correspond to this value. So this would be for Simpson 1/3 rule, the typical Simpson 1/3 rule. However, similarly with trapezoidal rule, we also have cases where instead of having only one segment, so this is, even though here you see that we have 2 segments, however, according to the Simpsons 1/3 rule, this is only 1 segment. In order for us to have, like, for example, we have 2 segments, therefore what happens is that we are going to have this first segment here. So this corresponds to the first segment, and this corresponds to the second segment. So what we're going to have would be the segments here. This if we try to calculate later on, it would be divided into 2. I'm going to show you how we can incorporate this into MATLAB codes later on. So H here, if we have several segments, so H is actually B minus A divided by the number of segments. So this is H. If we have 2 segments. So H. For the 3/8 rule, it's actually similar to what we have learned for 1/3 rule, so I'm going to skip on that. Now, can you go to your tutorial 5 and try to have a look on it And then maybe about 10 to 15 minutes later on, I'm going to show you on how we can use the trapezoidal rule to uh, find the value of the integration of the function. So I think, can you try to do that? So you need to refer to your tutorial 5. I think I have shared it in the spectrum. Before that, any question? No question. Just because this is pertaining to the hybrid classes. I know that previously I mentioned that I wanted to have a hybrid class. However, during that time, the COVID cases was a bit not that high as as of now, and also the dean is not that keen on having hybrid classes at the moment. In fact, I'm in quarantine at the moment because my son's classmate is positive COVID, so the whole house is in quarantine at the moment. But however, if let's say the COVID cases went down later on, I think we're going to have a hybrid classes, hybrid lecture or hybrid tutorial session where um, every week you need to register. Maybe I'm going to ask only 10 of you to come to the tutorial or the computer demonstration for MATLAB. But I'm not really sure whether it will be approved because the HOD, Prof. No, and also Prof. Saad are not really keen on hybrid learning at the moment. So I think that's the update for hybrid learning. So can you try to do the trapezoidal rule and also Simpson's one-third rule for tutorial 5? This tutorial is quite easy compared to the previous one. So this is quite easy where you only need to actually the only difference between these codes, the form would be the formula. So for example, for trapezoidal rule, you're going to use a different formula compared to Simpson's one-third rule and also Simpson's 3/8 rule. So I think I'm going to give you about 10 to 15 minutes to do trapezoidal rule and try to understand, and also another 10 to 15 minutes for Simpson's one-third rule. Okay. Can we start? I'm going to present now. Can you see my screen? Anyone?
Yes, right.
Yes.
Okay. Right. So if you try to write down the codings for trapezoidal rule, you will get something like this. And we are going to discuss this line by line. So the first line here, it's specifically mentioned that this M file is going to calculate where I is the formula for integration, and we are going to name that file as trapezoid rule. So trapezoid underscore rule. So this would be the file name where the value of I here would depends on the on four items. The first item is F. F here is the equation. A here is the beginning limit or the lower limit. B here is the end limit or the upper limit, and N here is the segments. So if the question asks you only to have a simple trapezoidal rule, therefore we are going to assume that N is equals to 1. So unless stated in the question itself that the segment would be more than 1, so you have to assume that it's equals to 1 if we are going to use a basic trapezoidal rule. So now line number 5 here is actually the equation. You may put the equation outside. However, when you wanted to call the file back, you have to put or type the equation in the command window. However, we can do it in the file itself. So this would be the equation that you wanted to integrate. So this equation is actually from exercise from tutorial 5. So exercise number 2A. So this is actually 2A. And number 6 here, when you run this particular file, MATLAB will ask you to input the lower limit, where the lower limit here would correspond to A, and the upper limit, whereas the upper limit will correspond to B, while N here is the total number of strips or segments. So if we refer back to the graphical representation here, it would be something like this. So A here is the lower limit, B, this is the equation, the function, and also the number of segments. So this, if we have 2 segments. If we have 1 segment, it would be a straightforward trapezoid. So this would be how you interpret the codes. And then H here is actually the height of the segments. So for example, if we have only 1 segment, therefore the height would be, or the width would be B minus A. So here, if we refer back to this particular graphical representation, so if we have 2 segments, the height here, H here would be B minus A divided by 2. So this is if we have two segments, so the width would equals to b minus a divided by 2. However, if we only have one segment, therefore h here would equals to b minus a. So it depends actually on the number of segments that you have. And this is a bit tricky, this part from line 11 until line 14. So what happened here, this at first, at the initial value, the integration value is 0. So if we refer back to this graph, at this point here, I is equals to 0. So this is what we wanted to tell MATLAB. However, as we move from A to B, so this is this line here, while in bracket A minus B equal less than 0. So this means that we are going to run the codes from A to B. The value of the integration would be equals to I. So I here refer to the initial I. In this case, it's 0 plus h divided by 2. So h divided by 2 is actually b minus a divided by n divided by 2. So if we refer back to the trapezoidal rule, this is actually the formula for trapezoidal rule. So divided by 2 plus from h divided by 2 times fa plus h. So this is the value of h. For example, if we have two segments, therefore we are going to calculate this part first. So I plus I, sorry, this I plus I so this is plus I plus, so the integration is actually I at the initial value plus I. So if we wanted to change it into MATLAB code, it would be I plus I plus h divided by 2 times fa plus f a plus h so this is for this first segment only. So this corresponds for this first segment, and then after we have calculated the first segment, we are going to calculate the second segment. So where the segment, for the second segment, a here, the lower limit would be a plus h. So this here, this corresponds to this. So we're actually going to have a loop where we are not going to calculate the value of the integration at the same simultaneously at the same time. However, it would be a procedure or an algorithm where we are going to calculate the first segment first, and then we are going to use the value that we already get in the first segment to calculate the value in the second segment. So that's why we're going to change the value of a here with a plus h. So this is h. And then we are going to continue with this iteration. So this is correspond to line number 12 until line number 14. And then we're going to end it. And later on, we ask MATLAB to print the value of I that MATLAB has calculated. So I'm going to save this file first. So trapezoid rule, and then I'm going to run. So for example, in this case, doesn't really, I'm sorry about that, I didn't put the, let me see, this is 0.2, so the lower limit here would be 0. The lower limit would be 0, and then the upper limit would be 0.8. And we are going to assume that we only have one segment. So the integration, or by trapezoidal rule, is if we only have one segment, is this 0.1728. So if you refer back to the exercise, can you please add on for trapezoidal, for number 2, can you add that the value of the lower limit is 0 and the upper limit is 0.8. Sorry about that, I've forgotten to put the limits. So since in this exercise, I straightforward ask you to do the trapezoidal rule without signifying the segments, therefore you just assume that there will be only one segments for trapezoidal rule, for wanted Simpson rule, and also the 3-at Simpsons rule. Now we are going to go to any question? Any question before that? Can you try to do that? Can you try to do it now? Yeah.
What's the limit again?
Yes.
What was the limit
0 and also 0.8.
Okay, thank you.
0. Can you hear me? 0. I just write here lah. So the limit for exercise. So tutorial 5. Number 2. A until C. The limit A here is 0 and the upper limit is 0.8. Okay, so please note that down. Did you get the same answer as mine? Zero point one seven to 8. Yes.
Sorry, for the equation in the while, why is it h over 2?
H over 2. Because h over 2 is actually this one, is it? This one.
Yeah, yes, that one. Why h over 2?
Because this corresponds to this equation, average height.
Oh, so it's the average height over 2, but then we bring the over 2 under the width.
Yes, yes, yes. We bring up the over 2, 0.5 to in front.
Okay, all right, thank you.
Okay. Yes, for all segments, for all questions, we are going to assume that n is equals for 1 for all methods. This is because we didn't specify the segments, but during your examination or your test, I might ask you to do, for example, trapezoidal rule for n equals to 1, n equals to 2, and n equals to 3, and then try to differentiate between these three, which one would be much more accurate. So if we have more segments, by right, it would be much more accurate due to the fact that if you refer back um, to this, just show you. If you refer back to this graphical representation, you will see that if we have only one, so if we only have one segment, it would be something like this. So it would be a straightforward trapezoid, and we miss out this part and this part, this part. However, if we have segments, for example, 2 segments, we can minimize the area that we miss out. So in a way that if we have a higher number of segments, therefore the accuracy would be much better. Okay, Inaya?
Okay, Doctor. Thank you.
Okay, so anyone else? Did you get the same answer as mine? Is my the one that
Yes, Doctor.
okay, right. Can we move on to wanted Simpson rule? So in that case, I'm going to give you about 10 to 15 minutes, and can you try to do that? The only difference with trapezoidal rule would be this part here. So if you refer back to the codes, you will see that the only difference would be the formula. So for formula, this part, this is all because this line here stating that we are going to move from A to B, and this the only difference, line number 13 until line number 14. So can you try to do that? So if you remember, for our, it's already there in the tutorial, but you still need to understand. So if you refer back to the tutorial, you will see that for wanted Simpsons rule, we have for line number 13, we have I equals to I plus H over 6. So this H here over 6 corresponds to H, this one, H B minus A is H if n is equals to 1. So H divided by 6, so we bring over 6 forward. And then we're going to see that since for uh, wanted rule, we are actually going to have 3 segments instead of 2 segments. I'm going to show you later, but can you try to do it yourself at the moment, and then we're going to discuss it about in 15 minutes time. I'm going to stop presenting. Any question? No? I just remember. Anyone knows, because that's okay. Can you try to do MATLAB first, and then we can, because I need to discuss your attendance later. Okay? Right. So have you tried to do the wanted method using MATLAB? Any problem with it? I'm going to present now entire screen. So this is a function for wanted Simpson's rule. So this is a bit similar with Trapezoid Rule. So I'm going to save this. So as usual, the first line signify that this is a function M file with I is the value that we are going to calculate, and we are going to name this file as wanted Simpson rule. And I depends on the value of f. F here is a function. A here is the lower limit, B is upper limit, and N is the total number of strips or segments. Just wondering, can you see my screen?
Yes, Doctor.
Because I'm quite worried that I'm talking to myself. Anyway, now from line number 5 here, this is the function that we wanted to integrate. So since we are going to use the similar function that we have used in the previous trapezoid rule, so we just copy paste that one. So remember that in order for you to introduce a function, you need to signify that particular value is actually a function by using a handler. So handler in bracket x, meaning that that function will have the unknown variable of x. So this would be the function. That is the function 0.2 and so on. And then you are going to ask MATLAB to ask the user to input the value of the lower limit, the upper limit, and the total number of strips, where the value of h is equals to b minus a divided by n to get h. And this is initial value, I is 0. However, as we move to the positive x-axis, the area under the curve will be calculated using this equation. So line number 12 here mentioned that calculation will run from A until B, and this would be line number 13 is signify the wanted Simpson's rule. So as you can see here, wanted Simpson's rule. So wanted Simpson's rule, if you remember, is actually, let's refer back to this, is this. So if you refer back to wanted Simpson's rule, in order for us to use the wanted Simpson's rule from this particular equation, it seems that we are going to divide the function into 3 main segments. So this is difference with n. This is just in the equation itself. So let's say that we have a graph here. And we wanted to find the value from A to B using wanted Simpson's rule. So what we're going to do is if it's a wanted Simpsons rule, what happens is that we are going to, this is only for n equals to 1. So if we wanted to use Simpsons wanted rule, we are going to have something like this. So fx naught and this one would be fx I, and this one would be fx2. So from here, you will see that if you try to compare with the MATLAB code, you will see that so we are going to focus on the second part, because the I here, I equals I correspond to the initial value. So since initial value for the first one, for the first iteration is 0, therefore we are going to focus on the second part. So h over n here is actually, since n is equals to 1, so remember that h is equals to b minus a divided by n. However, since we are going to assume that there's only one segment, therefore h would be b minus a. And then if you refer back to this equation, you will see that this lot here that is divided by 6. So we are going to move 6 to the front. So this is h over 6 plus fa plus f 4 times f h 0.5 plus a. So this is fa a plus h. There's something wrong here. This is fa plus a. So this is actually f a plus h here is actually the value of b, because if we refer back, this is actually, I think I got a mistake. I have a mistake here. 4 times a in bracket h times 0.5. So this corresponds to this. And the second one is plus a. So this is, let me see. Okay, that's correct. So h plus, because we are going to have 3 segments here. So what we are going to have would be 0.5. This is 0.123, 3 segments. So this one would be h it's not supposed to be 0.5 because this one, this would be 1/3. And this would be the width here would be 1/3 of B minus A. So this is actually, if we refer back, this is actually 1/3 over 3 plus A. Let me see again if I go. Because I might have mistakenly. So for Simpsons run 1/3, it's actually, because I think I have mistakenly put the 3 segments. It's actually have only 3 points. Actually, I have made a mistake here. That's why. Sorry about that. So I just. Okay, so let's say that we have this function and we wanted to have a 1/3 rule. So if we refer back to the slides, the previous equation, for 1/3 rule, we are going to have actually 2 segments. So we are going to have 2 segments. Myself, I got confused. So we are going to have 2 segments. So we are going to have this one is fx0 and this one as fxi and this one as fx2. So as you can see from Simpson's 1/3 rule, what we can see that the distance between A and also the middle point here is actually 0.5 B minus A. And similarly with this point here, 0.5 B minus A. So in order for us to calculate, to put it in MATLAB code, we are going to see that the first one, so this one corresponds to HB minus A divided by 6. So 6 here, we move it forward. FA is actually fx0 times F H 0.5. So this is the value here, the value of the width, 0.5 times H. H here is B minus A. So we'll get the width, and then we're going to plus it with A to get this value. What is the value of this? We put as X, X1. So this corresponds to this, and plus F A plus H. H here is B minus A. So this is correspond to the MATLAB equation here. So this is actually 0.5. And so if, as you can see that the only difference would be the equation of the integration equation. And if we try to run it, so we just save it and we try to run it. Oops, there's something. Okay, so minus. Let me see what did I did wrong here. H over 6 F A.
Doctor, I think you need
Yes.
to add another bracket at the end.
Yes, yes. I'm trying to H. This is 4 plus A plus H. This is A plus H. Outside. Try to do that again. So the lower limit would be 0 and 0.8. So it would be not similar. I think that's right. The one I. So it should be H plus. Yeah. Because I tried to, I think I've done it wrong. There will be another bracket.
Doctor, I think you should add another bracket after A.
This one, huh?
Yes.
One, well, still 1.3. Yeah, because it's so one-third Simpson rule is 1.3. And also trapezoidal rule is 0.17280. Did you get the same answer? Can you try to do that? Let me see. If this is 4 times. Yeah, should be right. So if you try to compare this with the one that we have derived, one over 6 FA plus A. Yeah, so it would be, as you can see that the one-third Simpsons rule, the integration value is higher compared to the trapezoidal rule due to the fact that the trapezoidal rule seems to neglect some of the value. So for example, here, it's neglect this part here. So that's why the value is lower compared to the one that we calculate using Simpsons one-third rule. So your job here is to try to do exercise exercise for tutorial number 5. So can you try to solve using MATLAB the same equation? However, in this time you have to use create Simpsons rule. The reason why I wanted you to do this, because maybe in your examination, instead of asking you to solve something, some equation, a certain equation using trapezoidal rule, I might ask you to come with your own codes with a given equation. So for example, in this particular tutorial, I didn't give you the codes for Simpson triad rule. So in the future, I might ask you to solve a certain equation, a certain function using a certain Newton closed integration formula. So we have actually more than 10 Newton closed integration formulas. So your job here is to know how you can integrate that particular equation into MATLAB. So this is for 1/3 rule. The third one would be triad rule. So if you refer to the slide, so if you refer to the slide, triad rules. If we try to make a graphical representation, be something like this, for example. So A to B, using a triad Simpsons rule. For triad Simpsons rule, we are going to have 3 segments. So previously 1/3 Simpsons rule, only 2 segments. So triad Simpsons rule, we are going to have 3 segments. So we're going to have 4 points. So if we refer back to the slides, our equation for triad rule would be I equals to b minus a fx naught plus 3 fx1 plus 3 fx2 plus fx3 divided by 8. So if you try to do that in MATLAB, you will see that you're going to see that h equals to 8 plus, sorry, not plus, h equals to f times this value here. So your job is to get or to devise how you will get the codes for MATLAB for this particular triad Simpsons rule. So this corresponds to fx naught. This corresponds to fx1, and this one fx2, and this one is fx3. So as you can see that the distance between each of the segment is 1/3. So previously we used 0.5. So you need to use 1/3 in order to get the width of the section here. For example, x1 is actually 1/3 plus a. Similarly, as in similar manner that we have done for 1/3 Simpsons rule. Now, that would be your homework. For your homework, can you try to submit it before midnight today? Is it okay? Class? Can you do that? Because we already done exercise number 1, exercise number 2, A and C. The only thing that you need to do left would be exercise number 1 and exercise number 2C. Is that okay? This would be straightforward. You can even do this after the class. Straightforward. Is that okay? Do you mean only odd number of points? What do you mean, Amir? Amir? Amir, I don't really understand what your question here, but each method will have different segments, and that segments correspond to the equations of its equation. So, for example, if for trapezoidal rule, if you refer to trapezoidal rule, we have only two unknowns, not unknowns, but the function 2 points. So if we have 2 points, therefore we are going to have only one segment. For Simpson 1/3 rule, we have actually 3 points, x0, x1, and x2. This is correspond to the equation. So if we have 3 points, therefore, if we try to plot it on the graph, we're going to have 2 segments. And if let's say we have Simpson's 3/8 rule, we are going to have, if we refer back to the equation, we're going to have 4 points. So if we have 4 points, therefore we are going to have 3 segments if we try to plot it on the graph. So it's not depends on the odd number, but it actually depends on the points that needed for that particular equation. Is it, does it answer your question, Ami?
Yes, doctor. Thank you.
Okay, welcome. Speaking of Amir, I noticed that in the first several weeks, you missed my class quite a lot. Are you okay, Amir?
I had a problem with my spectrum. I can't submit my assignment.
Okay, that's okay. Because I'm quite worried that you have any problem other than a technical problem. You okay, yeah?
Right now, I'm good.
Okay. Any question? Pravina? No? Inaya? Inaya? Biasa Inaya ada question. Inaya? Who else?
Doctor, can I ask something?
Yes.
For this particular code, we no need to type our function in our command window. We just
No,
type
yeah.
in our script only, right?
Directly. Yes, directly.
So means that if in exam you give a function, new function, then we just delete the previous one and type it inside and run it again.
Yes.
Okay.
So you have to make sure that you change the function lah. Don't use the one that you have used during your tutorial. Okay?
Okay. Thank you, doctor.
Okay. So
Doctor.
Ikhlas.
For example, for the trapezoidal rule,
Yeah.
if we don't specify the function there, and we don't specify the A input, B input, and N input,
Yeah.
can we call the function and straight away put the A over there, B, and then N in
Yes.
the command window?
Yes, you may use that, but I just wanted to show you different way on how you can call back the function without calling back the function in the command window. It's up to you actually whether you wanted to call it in the command window or you wanted to do it directly in the M function. The good thing about using if you wanted to call it in the command window is that you can it's very easy to change the equation. No need for you to do, you just, if you refer back to the previous tutorial that we have, we can actually use write the equation in the command window and call back the function easily. Yeah, that's a good question.
I see. All right, thank you, doctor.
Okay. Aida, usually Aida got question. Aida, no question, huh? Aida, no question.
And doctor, this is not a question, but can we have the final answer for 3/8 Simpson rule?
No, I don't. This is an exercise, Aida. So yeah.
Okay.
Yeah. Okay.
you.
Welcome, Kosim. No.
Yeah.
Gary. No question, is it?
Yeah, no question.
You're okay, is it?
Yes.
Okay, that's good. Faris, no. Shinyi, no question?
No question, doctor.
Okay, so I think that's it. Can you try to do this, and then I will open the submission link so that you can submit the tutorial before midnight today. Okay, I think that's it for today. Thank you very much. Bye-bye.
Thank you, doctor.
Bye.
Thank you, doctor.
Thank you, Doctor.
Bye.
Thank you, doctor.
Just forgot to stop recording.